So this is a model I got out of GrabCAD. So a big part with some prepared in SpaceClaim to do some beam extraction. There are a lot of thin solids, so solid shell, and a lot of solid parts here. So I meshed this, and it's about 1.5 million degrees of freedom. So some details here about the mesh, and with only 4 weld objects, I have created here 192 weld segments. So seeing some results, some details here of the mesh, and some weld results. So I will now do a bit more detailed demo on how this is done. So first we can have a look on the model. So we have all the solids and we have all the beam elements. So a huge number of solid parts and beam parts. Also, I have prepared some contacts. So these silo parts, these solid parts, are connected with contacts, some no separation and some bonded. But down at the framework here we have no contacts at all. I've also prepared a number of named selections because this is the most efficient way to work with large models. So using worksheet method to select out different entities in the model. So first I will show here I have a bolt flange where I will add some bolts, and then I have done using these worksheet methods, for instance how I've selected cross member, converted to edges, and filtered out all the edges needed for adding welds. So this also shows that I've done a face split in SpaceClaim to have an edge suitable for adding the welds here. Also, as we see in this model, I have activated not just the weld strength toolbar, but also here our Bolt Toolkit and the Rebot generator. So I will show how you can use all these together in one project. So now let's start to build the bolt flange. So for this, I'm using what's called a simplified bolts group. And here I can then, using this named selection, create multiple bolts in one simple load object. So what happened? It is now detected and connected, creating beam bolts at each of these hole pairs, matching from these two groups. So I can easily now change the load, or I can add embedding, what load steps to use, or changing the size of the bolts. Next, I will now start adding welds. So first, again now, since I have all my geometry selected in name selections, I pick these selections one by one. So this first group of welds is this tube to plate. So you can also rename this, this M12. So tube plate, 8mm. So next we do the gusset. So we have gusset face, single-sided. Let's do 5mm weld, structural steel. And if I pick the wrong group here, it will say here, this is not a valid group, missing reference phase for edge ID and so on. So it checks that the reference phase is connected to the weld section. Okay, let's name this gusset 2 tube. Okay. What's next? Plate to tube. Again, we're using 5mm. So worth noting also is that we don't need to have perfect match here. This plate is all edges here are 90 degrees, so it's not a fit to this solid part, but it's a small gap. And the same for this tube part, that it's a planar cut, but as we can see, this face here is slightly curved. So plate to tube, and finally the cross member. So we have here the length. Here I can also select maybe, only using 2 elements to save some degrees of freedom. This is also a case here where the free end offset is good to use, because out in the corner edge here, the weld would be hanging in the air. So if I specify this free end offset, the weld is indented and not hanging out in the air, these places. So these are now all the welds needed for this frame. So now I'm ready to solve, but I'll do one more thing before I solve, and that is to prepare for reporting. So I will now quickly demonstrate how I initiate a report so I can get a finished Word report direct from Mechanical. So this report generator reads out information from the model. So here I, for instance, have typed in the author and this subject or prepare for. I give the report a name, revision number, who's the name of the reviewer. I can now add information to the introduction chapter and the summary and conclusion, so I can add text, do formatting. If I have some reference, if I don't want to include a part here, I can untag it. So this report generator works with these standard features of comments, figures, images, and tags. So I can here set my view of an image, and then I can go on and specify what to include in the report. For instance, if I want the image of all the solid parts. And the same for the beam parts. I set the view for each figure independent. And also making sure that every object I want to include in the report has the tag report. So I can go on here, add for instance a figure of the contact. Let's add one for the mesh. So also I can use the feature of grouping. So let's group the structural loads. So and group the boundary condition. So and let's add one image for each of these. So multi-selecting and getting now an individual image for each of these objects here. So if I want to do a specific hard copy here, I can easily now convert and use this hard copy doing specific image formatting. And I can go on now do the same here for post-processing. So by preparing a group, calling like this global results, tag it, add figures for these result objects, I get a ready structure in the model here. And I can also tag, for instance, these simplified bolts here. So doing here or doing a conversion to a snapshot. And of course I can add in comments writing about a result, writing about the mesh and so on. So now I'm ready to solve this, and I will now save some time, so I will switch over to this already solved model. So here it's in the solve state. So I have here these 3 different load steps here about gravity, wind load, snow load, and of course can review results for each of these steps. I can look on the detailed results, this results file, so I can zoom in on the welds itself if I want. So we see here our welds are created. And I also prepared a weld result for each of these groups. So in this case here I've selected the maximum over time, so I'm looking at the worst case scenario for all the welds. So these are okay. Here we see some local hotspots are a bit above 1. This cross member welds with intermittent wasn't a good choice, so here I need to do an update to go to a continuous weld, for instance. So when I'm done here evaluating, I can simply now do the hard copy to get a report of this analysis. So this report generated now exports every image, extracts every information from all the objects, and put it into my company's Word template for engineering reports. So Word opens up and the report is done. So I have my front page with the information about the names and the project. I have my table of contents, and I see here the structure about the different chapters: geometry, material, connections, mesh, structure, static, solution, and the different groups, subheadings here for global, local weld, weld utilization. So here I also added a bit of text to the introduction and to the summary and conclusions. And then follows the description of the model, automatic extraction of the part list I've listed and the material properties, contact the mesh pictures, and also what global mesh settings that would use, analysis settings, our loads, and for each load it also then extracts the load table. So our fluid load, the wind load, snow load, our supports. And also here for our the bolt and the weld objects, not just a picture but also a table here of properties for that object. So I easily see here the figure of my welds. I added this notification here, so this graphic annotation that you can add to an object. So my welds, and then onto the results. And for the result objects also we get this table saying here what weld code, what material, and so on. So if I'm happy with this, I can now simply save it here. Replacing it and distribute it. So this report is automatically saved into the project folder. So going here into the project file, it's located here in the user files folder. Or if I want to go on edit the Word report, it's also saved here with the project. I also find every image of the report, so I can use this for other purposes as well. So that concludes this big demonstration. So the speed up building and post-processing using these tools is a factor of 10 at least compared to doing this in creating geometry and all these manual steps. So the return on investment for buying this app is, I mean, one project and then you're earning money. So also not just speed up, but you also get the easy to view result plot and listings. Easy to do this external post-processing of these results in mechanical and plot it back in mechanical. The possibility to do optimization, updating the model, and we can also use it together with our other Weld app, the Weld Fatigue app. So using the geometry for creation of effective notch models and use submodeling, for instance. And as I've demonstrated how we can use it together with the report generator for getting a good report out of the mechanical model. And also how we can export the weld geometry and weld lines for other purposes such as drawing preparation.